Howdy folks, Mr. K here with a online video about gas laws. So, to understand the gas laws, first you got to know about the different properties a gas can have. First of all, gases, you have to know about the volume of something, or how much space the gas takes up. So this circle represents a volume, a container holding our gas. Within here we have, little gas particles. They're flying around all over the place, and they're pushing on the walls of the container. So when gases fly around, they hit the walls of the container. How hard and how often they hit the walls of the container and each other, that's the pressure a gas exerts. And finally, you have to know how quickly the gas is flying around in there. The speed at which the gas is flying is called the temperature. Temperature measures average kinetic energy. Kinetic energy is the energy of movement, so the higher the temperature, the faster the gas is flying around. The harder that it's hitting the sides of it, the more pressure it has. The larger the container, the less often it hits, the less pressure. The smaller, the more often it hits, the higher the pressure. So, let's talk about the actual laws themselves. First up is Boyle's Law. Now, as Boyle's Law tells us the relationship a gas has with its volume and its pressure. And notice for Boyle's, you do not change the temperature in Boyle's Law. It stays constant. We find, according to Boyle's Law, that gas varies inversely with pressure, meaning that if pressure increases, volume decreases. Or if volume increases, pressure decreases. Think about it like this. If you have a balloon with some amount of gas, remember, pressure is how often the gas is hitting the sides of that balloon. If you keep the amount of gas the same but put it in a larger balloon, there's going to be less hits. Since there's less hits in the larger balloon, because there's more space, there will be less pressure. The larger balloon, this increased the volume, but it decreased the pressure. Something that's inverse means that they move opposite of each other. Boyle's Law states, once again, constant temperature, the volume is inverse with pressure, meaning if I increase volume, I decrease pressure. Next up, Charles' Law. Charles' Law tells us the relationship between volume and temperature at constant pressure. We find that, according to Charles, that volume and temperature are directly related. So what that means, if temperature increases, then volume increases. That's direct. They move in the same direction. If temperature decreases, volume decreases. If I have a balloon and I chill it down, if I lower the temperature, well, that gas is going to not have as much energy and not be pushing the balloon as much, making the balloon a lot smaller. When I decrease in temperature, I decrease volume. Final law that you need to know, Gay-Lussac's Law. Gay-Lussac states at a constant volume that pressure is directly proportional to temperature. Meaning, if I increase the temperature, my pressure increases. If I decrease temperature, my pressure decreases. Think about it like this. Remember, if I have a container and I have a gas in there, and I'm at a very high temperature, means it's flying around very rapidly, hitting a lot very quickly, I'm going to have a very high pressure. This is at a high temp. If I lower my temperature, my gases do not move around as quickly. They don't hit the walls and each other as often. Here at a low temperature, then, I'm going to have a low pressure because there's less hits. That's what Gay-Lussac says. The lower the temperature, the less pressure. The higher the temperature, the more pressure. Okay, folks, that's a brief overview of the gas laws. From here, you should be able to tell me what the three laws are and what they say about the relationships between volume, temperature, and pressure. I will see you in class.